So, good morning, everyone. We are Group 5 from VIT Pune. Today, we are presenting our case study on Satkam electric scooters. I am Aman, and with me are Advait, Sushrut, and Tejas. So, let's dive into the new version plan we have crafted. Also, we had recorded a detailed explanation video whose link is mentioned in this slide. So, let's start with question number one. So, the question is the company wants to do an analysis of the apps and what it needs to improve it. Mind map the top 10 features you would want in the app and the electric scooter and explain which are the top 5 features which would be most useful and why. So according to us, the top 10 features will be smart ride statistics, predictive battery drain alerts, nearby charging station locators, Google Map integrations, maintenance scheduler, GPS tracking, then ride mode selectors, digital document vault, and real time battery status. So according to us, these are the top 10 features, but the top 5 features which we have selected are predictive battery drains and alerts. So basically, this feature will warn rider in advance if their battery is likely to run out before reaching their destination, helping avoid getting stranded in mid ride. So the next important feature will be Google Map integration. This will enable in-app navigation with route planning, traffic updates, and estimated time of arrival directly from Google Maps. The next will be charging station locator. So it will help user find nearby compatible EV charging stations in real time, making it easier to plan longer trips. Then another feature that is of great importance is OTA, that is over the air updates. This will allow the scooter software to be updated remotely via the internet, delivering new features, performance improvements, or bug fixes without visiting a service center. So the last feature will be ride statistics. This will track and display data such as distance traveled, average speed, battery usage, and ride time to help user monitor their ride habits and scooter performance. So now Advait will take up.
Moving on to question number two. What are some of the design considerations you would have for designing the storage feature, and what all will you need to consider for security of the documents while designing the architecture? So while designing the storage feature for the electric scooter app, we need to think both from the user perspective and the security perspective. So we have a few design considerations in mind. The first consideration is that it would support multiple file types. So the app should allow uploading important documents in PDF files, like insurance papers, vehicle licenses, and even personal ID proofs. These documents should be accessible both on the app and the viewable on the dashboard. And moreover, it is also important to sync these documents across devices. Additionally, we should also have a offline access fallback plan in case of internet connection lost. Moving on to the security measures, since we are dealing with personal data, security is absolutely critical. So for that, we shall ensure end-to-end encryption, preferably with AES 256 standards, to protect document data during transfer and storage. Then we should ensure that the cloud storage is secure. The storage backend should rely on trusted cloud providers such as AWS, Google Cloud, etc. For authentication, we shall implement two-factor authentication using fingerprint or biometric locks to prevent unauthorized access. And we should also implement role-based access, which can distinguish between normal users and administrative service users. All APIs connecting to the cloud should go through secure API gateways, and we must apply rate limiting to prevent abuse or hacking attempts. In short, the document feature must be simple for users, but also extremely secure under the hood. Moving on to the question number three. List the potential reasons for any two of the issues in which the customers have complained about and write the test scenarios you would use to test and ensure they have been fixed. So the first issue is the app showing outdated data. So the root cause for this issue is likely caused by poor backend synchronization, where the app is not pulling or pushing real-time updates from the server. So the test scenarios, firstly, we would stimulate internet packet loss. So switch network off and on and check if the app resyncs properly afterwards. Secondly, we would trigger multiple events from the scooter, like locking, unlocking, or trip completion. So, and verify if these updates instantly reflect on the app. The second issue is that the charge run out suddenly and the charging takes more time. So the root cause of this would be a faulty SOC, meaning state of charge estimator, which could be incorrectly predicting the remaining battery life. For the test case scenarios, the first test case scenario would be deliberately discharging the battery down to a low percentage and monitor if the low battery warning pops up early enough and in time. Also, we would also simulate fast acceleration on low battery to check if the app alerts the user that the battery might not last the trip. So by running these test scenarios rigorously, we can ensure that the new version of the scooter provides a smoother and a much more safer experience. Moving on to question number 4. Use the inside out and outside in technique of releasing a product to the market and list the top 5 things you would do inside out planning to release the new app to the market and the outside in planning for releasing the new app. So the inside out planning, which is the company focused approach. Firstly, we would define KPIs such as faster reload time, lower crash rates, and improve user retention. Then we would build an MVP, a minimum viable product that includes only the core features such as navigation, etc. Next, we would conduct internal QA testing with simulated rise and rough usage patterns to stress test the app. Following that, the internal staff training would be done. So there would be organized employees to understand the new functionalities before the launch of the app. Finally, we would run an internal beta release where only company employees and selected users with beta access would be using this app to find bugs. Speaking of the outside in planning, which is the customer focused approach, we would first conduct user interviews and surveys to understand what users truly expect from the app. Then we would A and B test two slightly different versions of the app and observe which one the users prefer. Next, launching an open beta program for early adopters can give us real world data much earlier. Following this, we can collect the feedback from the open beta program and use it for a further step. Finally, we would market the app heavily and on digital channels using demo videos and user testimonials to build excitement. So using these two complementary approaches together ensures that the app is internally stable and also loved by users. Moving on to the next question.
So the next question is, based on the list of the top 10 features we have selected, do a relative priority exercise to mark them from P1/P2 and from 1 to 10 and explain what you have decided those priorities. So the first rank and priority P1 goes to like battery alerts. Then second is P1 Google Maps. The third is P1 charging station. Fourth is priority one OTA updates. Fifth one is priority one digital documents. For P2 priority, we have on sixth number ride statistics, GPS tracking. At 8, we have ride mode selector. At 9, we have maintenance scheduler. And 10th, we have UI customization. So in this, we will prioritize the top 10 feature based on the direct impact on improving the customer experience, resolving existing complaints, and supporting the company's goals of increasing sales and profitability. So these features critical to safety, user satisfaction, and operational efficiency, like battery alerts, Google Maps, charging station locator, OTA updates, and digital documents are marked as P1, and features that enhance the user engagement and build a long-time brand loyalty, like ride statistics, GPS tracking, ride mode selector, maintenance scheduler, and UI customization as P2 as secondary priority. So within each priority, we also mark them on 1 to 10 based on the urgency and the frequency of use and customer value contribution. So this ensures that we have a balance between innovation and solving the key complaints. So the next, moving on to the next, so the company is collecting the data in the cloud already, but have had performance issues to update, collect the data, and update the app. What can be the reasons for that, and what would need to be improved for the data integration from the vehicle to cloud and then send data post analysis to the app? So the possible reasons for this are like a poor API design, unoptimized queries, small packet overload, and weak data handling. So improvements that we would do are like edge caching, optimized APIs, MQTT for real time, and auto retries. So the performance issues in this updating and collecting data from the vehicle to the app could occur from like the factors that I discussed above. So to solve this problem, we'll like implement edge caching, which is like processing data locally before sending to the cloud. We'll also try to optimize the APIs and like optimize the queries so the data is sent faster. And we'll also try to do lightweight data transfer, and we'll also set up auto retries to handle the internet failures smoothly. These improvements will make the system faster, more reliable, and better equipped to deliver a seamless user experience. Moving on to the next question, the company would like the app to have intelligence and provide recommendations to driver. What kind of data should the app collect from the vehicle, and what kind of recommendations can be done? Is there a possibility to use ML or AI for the analysis? And if so, what can be the use cases? So to make the app smarter, we propose collecting data such as battery health, ride behavior, routes, and environmental data. So using this data, we can provide actionable recommendations like switching to eco mode for better efficiency, battery service alerts before like the actual issue arises, uh, uh, and also suggest safer routes based on real-time conditions. So we can apply AI and machine learning. So we can also build models for predictive maintenance. So they can predict failures before they happen. We can also have adaptive range estimation. So in this, a more accurate remaining range calculation would be done based on the driving style and the environment, and the UI adaptation. So personalizing the app interface based on the user habit. So this will overall greatly enhance the rider's experience. Over to Tejas.
Eighth question. Use the product solutioning concept and create a mind map for a new version of the vehicle explaining the goals, features, UX changes, and UI changes, if any, you want to target in the scope. Our mind map for the new vehicles target three core goals: boosting market share, achieving zero defects, and ensuring the uh, profitability. The key improvements focus on faster charging, lighter vehicle design, and intuitive dashboard with UX enhancement like voice feedback and dark mode. Let's move on to the next question. What Question 9: what can be the business and operational metrics and measurement the company can use for the new version of vehicle and the goals they have for it? Business metrics can be around revenue, profit, etc., while the operational metrics can be around quality, deliver time, etc. What all can be the metrics which the companies measure their performance when manufacturing and selling electric vehicles? So lastly, we identified the important metrics: business metrics and operational metrics. So on the business metrics, the monthly sales per unit profit, customer lifetime value, and market share will be tracked. On the operational side, average charging time, service ticket rate per thousand scooters, app crash rates, and first 3 month defect rate are key indicators. Next slide. Thank you for your attention. We believe this solution will enable electric scooter to not only move up to the second place in the market, but also achieve sustainable profitability. Thank you.